All right, folks, this is a video for the Unit 8 Mom Review. Let's roll. So I've um, produced this version of the mom. So of course all of yours and your numbers and your answers and your questions will vary, but this should help. Number one is matching. Matching these four items. Let's start with the type of error. I always think when I do my null and my alternative, they go in order like one and then two. So that always helps me know. I don't know. Type one is when you reject the null, when you shouldn't. Type two is when you reject the alternative and you shouldn't. So C is type one when you reject HO, but it's true. And then B is when you should have rejected the null, but you didn't. So you're kind of rejecting the alternative. Um, part letter A is the p-value, and I drew this picture to try to help you with it. It's the probability. Every time we do a test, we get a p-value. And what is that? We place the null in the middle of the curve because the curve is operating under the assumption, that p equals whatever value it is. We'll just make up like 0.70. So this would be 0.70 in the middle of the curve, right? And then you go out and you get a sample. Let's say, just make this up, we get 75, which is higher, right? So it's above the null, okay? So then our alternative is, well, hey, I think the proportion is above 70%. So this orange shaded area is the probability of getting a sample located here or greater. So it's the probability of getting this result or more extreme is why it is shaded to the right. And so that is A, which I already put in there. And then process of elimination, this is D. Alpha, whatever you set it at, say you set it at 5, which is the most common, 0.05, then you will make a type 1 error 5% of the time. Because if, um, let's say you get a p-value of 4%, that means that this result will happen randomly by chance 4% of the time if the null is true. But you've set your cutoff at whatever alpha is, say 0.05. So if you set your cutoff right here at the green line and at an alpha of 0.05, then you are going to reject the null 5% of the time when you shouldn't. So that's what that means. Two, you got a random sample of, I have 300 adults and we made a 95% interval. What is the point estimate? Well, here's the interval. So I drew my interval, and the point estimate, folks, is simply the middle. As soon as you draw this, I think you're like, oh, well, that's pretty easy. Just add them up and divide by 2. And so I'm going to get 0.70. It says rounded 2 decimals. Mine is pretty clean. B, the margin of error, would be plus 0.05 and minus 0.05. So, on your calculator, if your decimals are not as nice, you can just take this one minus this one. You could also take this minus this divided by 2. Just various ways to do this. 0.70, 75 minus 0.70. Well, my goodness, that you could also do 0.75 minus 0.65. That's the entire length of the full interval divided by 2 because it's got 2 margin of errors. So hopefully you'll get 0.05, or I get 0.05, you get yours. Next question. If they wanted to do a follow-up study in which you kept the confidence level constant, but the margin of error was only 0.025, what size sample would they need to take? So when it says the confidence level remain constant. What does that mean? It means Z star does not change. So we had 95%, right? So we're going to leave it. I had 95. I don't know what you had. My Z star for that is, right, what is Z star for that? It's 1.96, the most common one. So that's going to stay the same, but I'm going to change my margin of error. Mine was 0.05. It looks like I'm cutting it in half. I'm not sure if that's going to be the same for all of you, that it's dividing by 2, but mine is. So the margin of error formula is the Z star times the standard error. If you're wondering where this is in your cheat sheet, this would be a good thing to look at. So they give you here the basic interval formula, right? Your statistic is your p-hat, your critical value is your z-star, and then the standard error, this is the general formula. To get the specific formula, you got to look down for what is the standard error when you're doing a p-hat, and it's right here. So you do have to piece it together, okay? But that's where I got this. So, my z-star remains the same, and when I change my sample size, it will have no effect on p-hat, right? In other words, the center of this interval should stay at 70%, right? It should just remain there. By taking a smaller or larger sample, it should always point to 0.70%, if 70% is the truth, of course. So this is going to be the same. It's going to be 0.70 and then 0.30 for me, 1 minus 0.70 divided by n. And then you have to go through the nitty-gritty of solving this. On the calculator, I'll go through mine. You can follow along with your numbers. First, I divide by my confidence level. That'll take care of that. Then I'm going to square both sides to get rid of the square root. Leave it running on the calculator, this running number, okay? At this point, I have that decimal, 1.62, blah, 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 times 10 to the negative 4 equals, and I really have, if you multiply these, I get 21, right? 7 times 3. So I have 0.21 over n. At this point, you can simply switch these two. So I'm going to just take 0.21 and switch them. So divide by that decimal. And I haven't rounded any at all. And so you get 1290.7 for me. You'll get a different value, of course. And you always have to have an integer value here when you type it in. So always round up. So I would have 1291. Like even if I had my calculator said 1290.1, I would still round up to 1291. Because if you round down, you are actually going to be making your margin of error go up a little bit, because sample size and margin of error are inversely related. As the sample size goes up, the margin of error goes down, and vice versa. So as n goes up, margin of error goes down. All right. Number 3, it says express this in interval form. So 0.58 is simply the center, and the 0.05 is the margin of error. So pretty easy here, I think. Add 0.05 and subtract 0.05 to your point estimate or whatever they've given you. And then interval notation would be parentheses. So mine goes from 53 to 63, like that. Rounded 2 decimals. All right. Number 4, we got a streak of questions about when the interval will get wider or narrower or stay the same. So suppose we have a confidence interval that had a sample size of 52. So I'm starting here. What will happen to the interval if the sample size increases to 84? So I'm going from here to here. The point estimate will stay the same, as I said earlier. Sample size will not change what the point estimate is. Every sample should theoretically accurately point to the truth. If, for example, if I am a 70% free throw shooter, all my samples should point to that 70% success rate. Whether I take 20 free throws or 100 free throws, the center of all of these samples should be 70%. So the point estimate doesn't move. What will change is the margin of error. It'll either go up or go down. And from earlier up, remember, this is the margin of error formula, okay? Changing the sample size does nothing to Z star, and it does nothing to P hat. So the only thing that's changing is the green numbers of the sample size. So it started at 52 and it reduced, and then it grew to 84. So you can see here that I'm dividing by these numbers. So this one on the left will actually be bigger, right? Because I'm dividing by a smaller number. And this one will be smaller because I'm dividing by a bigger number. So it will get narrower because my margin of error gets smaller, right? If this margin of error became smaller, then the interval would shrink. Okay. Number 5, this is saying, what if you change the actual confidence level from 97 to 99%? So you're messing with the Z star. You're not changing anything else. The Z star for 97 is 2.17. The Z star for 99 is 2.576. If you forgot where to get these, you can look in your College Board packet, and you look to the infinity row right here. Infinity row is where all of these are the Z stars. And so you can see, like, here's 95, the most common one, and here's that 99 that I listed. You can see as you move this way, what's happening to your Z stars. They are increasing as you go to the right. They're getting bigger. 97 is not on here. It would be in here. You can kind of see. I had to use my calculator, if you're curious, um, to get this value. What I actually did, this might make your head blow up, but it's worth it. 97% confidence interval means where's the middle 97%? So on the calculator, I actually said, okay, then this and this would make up 3%, or this is 0.015 on both sides. Because, right, 3 divided by 2 is 1.5, right? And then I did that in percent. And then I did the inverse normal button for 0.015. And yes, it's negative. So this is negative 2.17 for my z-score, and this is positive 2.17. So that's where I came up with, if you're wondering where that 97% came from. And you might not even have 97%. I don't know what your version is. Number 6 goes from 99 to 96. So 99 and 96, they're both in the formula packet. Oh, whoop. That should be a 96. Sorry, I was doing some copy and pasting there. So the Z star goes down, it decreases. If everything else stays the same, right, and your Z star goes down, what happens to your margin of error? It will go down, which will make your interval narrow. Yeah. You can also think, like, if your confidence percentage goes down, you're less confident. So that means the search area, or the interval, so to speak, is smaller. Number 7. This is back to sample size. It starts at 62. So I wrote down the margin of error with the 62, and then it decreased to 20. So this is the second one. So again, I think I said this earlier. The margin of error is inversely related to sample size. So if you decrease sample size, which is what this is doing, it's going from 62 to 20. If you decrease sample size, margin of error goes up. And if margin of error goes up, the interval gets wider. Number 8, moving on to finally different context. We're doing like a full write-up here. It's believed that 18% of all Americans are Democrats. Okay. In a random sample of 500 students from a particular college with a lot of students, probably go U of M or something, 83 were Democrats. It's a sample of 500 and 83 are Democrats. This is the population size, okay? This is the population. The whole school is the population. Find a 94% confidence interval. Well, that's an ugly number. We'll work with it. For what? The percentage of all students at this particular college who are Democrats. What is the correct parameter symbol? It's P, right? P is for the parameter. P hat, this is for the sample. So don't get those mixed up. It's not these. These two are for means, and that's not what we're doing. What is the wording of the parameter? So what I did is I just highlighted it. When it says find an interval for something, typically whatever comes after the word for is the parameter. It's the percentage of all the kids at this school that are Democrats. What conditions do we need to check? With a proportion, there's these 3. So large counts means 10 successes and failures. Independent, we usually do independence, doing this bad boy, and then random. Now, you might be like, wait a minute, I have this and this that look the same. I think this is splitting hairs. Whoever authored this question, they chose the answer to be this. This would be expected counts, if you want to know the difference. This is based on the null. This is what you would expect to happen. And this is the true actual counts. I think on an AP exam, if you're writing up an FRQ, you can do either one and you won't get into trouble. But for your purposes of getting it right on the mom, you want to do the P hat ones. Even furthermore, this would be expected successes. And this one would be expected failures, or people that are not Democrats. Okay, the conditions are met to use what? Is it a 1 sample or a 2 sample? If you read it again, there's only one sample, a sample. So 1 proportion. The symbol for the point estimate, that's your p hat, okay? P hat is the value of the statistic from the sample. The interval estimate now yours looks different. Yours is like a drop-down box. The interval estimate for what? The interval is, again, look back up here. What are we estimating? This is an interval for what? What I highlighted is P, the parameter for the whole population. So here you're going to pick the parameter for P. Sorry, the interval is estimating P. The interval that we're making is estimating the parameter, which is P. And then what is it? So at this point, I'm just going to use the calculator and use the correct test button. Stat tests, I named it, where 1 proportion is the interval. So that is button A, capital A. What were the numbers again? For me, I had, right there, I had 83 Democrats. Here, let me rewrite it. Oh, I had to find that. Duh, right here. My P hat, and you did too. My P hat is 83 out of 500. Hashibudu, 83 out of 500. That's my point estimate. And I'm doing a 94%. You have to put in whatever they gave you. So my calculator right there, it gives me p hat. So that can help me back up here. Mine is 0.166, so 16 or 17%. My confidence interval, as soon as you run it or calculate it, that would be your answers right here. So mine is 0.134. Oh, I'm rounding to 2 decimals, so mine would just be 0.13 to 0.20. There you go. All right, one more. Past studies have indicated the percentage of smokers was estimated to be about 33%. It seems way too high. This must have been a while ago. So I highlighted it. That is the null. Past studies have indicated. This is kind of speaking very generally of the entire population. There's new smoking cessation programs that have been implemented. People don't smoke as much now. We now believe the percentage has reduced. So that's going to be your alternative. It has gone down. Here's yellow is your sample, and we're going to use an alpha of 0.05. So the null is that P, let me see, how does this look for you? For you guys, it's, it's like a drop down, right? So you pick P, and it equals, it's never less than, it's never greater than, it's P equals, and then 0.33. The alternative is that it has reduced, so you have taken your parameter and it has gotten smaller or less than 0.33. Do not take the p hat, which is this value. The p hat is 0.308, right? That is the statistic, and that's important, but that is not, that never comes up in the alternative. You simply say, did it get smaller or bigger? Is this left-tailed or right-tailed or two-sided? So what we have here is we have the curve set up. The null is in the middle, so we believe the middle to be 0.33. My sample is down here at 0.308, and it is only shaded on the less than. So this is left-tailed. It's a one-sided test. Use the appropriate significance level. For me, it's set it in the directions. I'm not sure. As I look at my question and I'm clicking through, I'm getting some new versions. It seems like most of you are going to have 0.05, if not all of you. Okay, calculate the test statistic. So if you are into maybe trying to figure out the formula, you figure out how far your data point is from the mean, and then you divide by the standard deviation. And the standard deviation formula is, it's based on P, not P hat, okay? Is it 500 people? Oh, whoa, it's way more than 500 people. My sample size was 1754. Okay, now this would be an FRQ thing. You don't really need to write this for a mom, but the standard deviation is based on the curve, and the curve is centered at the null. So I'm going to use that down here if I was to show my work, or if this was a multiple choice question. So the formula that you would be doing is 0.33 minus 0.30. So I'm, I did that backwards, sorry. My sample was 0.30, my parameter is 33. So in other words, this, maybe a little more precise, it's 308. So my sample is like 2 to 3%, right, below the parameter. And then I'm going to divide by the standard deviation. which is going to be 0.33. 1 minus 0.33 over 1754. When you do the test on the calculator right now, this is what your calculator is doing. It's doing all the grunt work for you. So let's do that. Stat tests, it's a one prop Z test. That's button number 5. Then P0 is the null. So that's my 33. X is the number of people in the sample that quit smoking. Sample size was 1754. All right, and there you go. So that test statistic, that is my z-score. Round it to 2 decimals. So negative 1.92. P-value is right there, 0.054. Oh, that's close to 0.05. So my p-value is slightly bigger than alpha. So we will not reject the null because the p-value is not less than the significance level for my data. You might be coming with different results. So the conclusion is that we're not rejecting the null. So do we have evidence that the smoking program is reducing alcohol smoking? No, we don't. We do not have evidence that it is reducing smoking. So there it is, folks. And I believe that is the last question. There you go.